Welcome to solverfy.
Okay, so problem number 2 wants us to calculate the wavelength of a 28 giga electron volt electron, or 28 giga electron volt electrons. Sorry. So now so what this means is that it wants us to calculate the de Broglie wavelength, which is related to the momentum by this expression. So now, in order to get we need to understand the momentum in terms of the energy of the electrons. So we need to look at the relativistic energy because these are very, very high energy electrons. So the total energy of a particle is given by p squared c squared, the square root of p squared c squared, so the kinetic energy, plus the potential energy, or the rest mass energy, m0 squared c to the 4. So now the rest mass of an electron is given by 0.511 MeV per c squared, which is much, much less than the 28 giga electron volts of the kinetic energy of the electrons. So because of that, the kinetic energy is going to completely overtake the potential and the rest mass energy here. So this can actually be treated as just 0, and we can say that the total energy is just the kinetic energy, which is just equal to P times C. So now energy is equal to P times C, so we have P is equal to H over lambda, so this is just equal to H times C over lambda. So now we can rearrange this a little bit to solve for lambda, because that's what we want. We have lambda is equal to hc over E. Now we just plug in what we know. Planck's constant, 6.626 times 10 to the minus 34 joule seconds, times the speed of light, which is 3.00 times 10 to the 8th meters per second, divided by the energy, which is given to us as 28 giga electron volts, so 28 times 10 to the 9th electron volts. Now we're in units of joules, so we need to be in units of joules, so we'll convert that. Convert that by multiplying it by the relation of 1.60 times 10 to the minus 19 joules per electron volt. So those cancel. The joules cancel, the seconds cancel, and you just end up with meters. So the wavelength of a 28 giga electron volt electron is going to be 4.4 times 10 to the minus 17 meters, or 44 attometers. I'll just call it AM. Attometers. So very, very, very short wavelength, very, very, very high energy electrons.